Aquatic life is possible in water because we have presence of dissolved oxygen in water. Now this dissolved oxygen which is present in water depends upon many factors. For example, temperature, the amount of sediment and the quality of the sediment that is present, and also the oxygen which is giving out of the system with the help of the respiring microbes and the oxygen which is putting in with the help of the photosynthetic bacteria. So this presence of dissolved oxygen holds a very important place for the sustainment of the aquatic life in water. Today in this program, we are going to discuss about the two different important tests which determines that how much amount of oxygen is present in water, and that in turn interprets whether the life form is possible or it is not possible in water. These two tests is referred to as the BOD and COD. Now, the wastewater refers to the water which is coming out from the domestic household and from the industries. Now, water exists in two basic forms. One is the groundwater and the other one is the surface water. The groundwater is not subjected to pollution and therefore it can be used as a potable water. That means the water which is not contaminated and that can be consumed or that can be used as the drinking water. However, the surface water is very much exposed to the pollution and therefore the contamination in this surface water is present in a huge amount. But the wastewater which is coming out from the household and the industry, if this could be assessed, if this could be treated properly, can be used for other purposes like for irrigation or as recreational water. So there are four major categories by which we can assess the wastewater. These categories are as follows. Number one is your nutrient, that is the amount of nutrient that is present in water, whether it is nitrogen or phosphorus, because they occupy a very important place for the aging of the water body. If you have enough amount of nutrient, more microbes, more biological entity will grow and therefore this leads to eutrophication. Okay. The second category is the physical property. That means what is the temperature of the water? What is the pH of the water? What is the salinity? So all these physical parameters also determine the type of water that can be assessed. The third category is the assessment of the solid. Here we determine the total solid which is referred to as the TS. The TVS refers to total volatile solid. TSS is the total suspended solid. And the TFS is total fixed solid and TDS is the total dissolved solid. So basically we assess the different types of solid matter that is present in that water sample. And the fourth important category that we are going to learn today is the organics. The organics take into account the various tests like BOD, COD, TOC and ONG. Now let us learn our process with the fourth category, that is organics. Now organics takes into account the determination of the concentration of the carbon based compounds which ultimately establishes the strength of the wastewater. Whether this wastewater could be purified, can go in for the primary or can go in for the secondary treatment. And the most important test for this is BOD, which is biochemical oxygen demand. Chemical oxygen demand is COD, TOC is the total organic carbon and ONG is the oil and grease content of the water. Before we go into the test process, let us first learn what is dissolved oxygen, which we refer to as the DO. Now this dissolved oxygen which is present in water depends on many factors. The most important factor is the temperature. As we increase the temperature, the dissolved oxygen that is present in the water keeps on decreasing. This can be very well seen when you boil the water, the effervescence come out. That means as you increase the heat or as you increase the temperature of the water, the oxygen is liberated out or the amount of dissolved oxygen that is present in water decreases. The second most important factor is the salinity, the amount of the salt that is present in water. If you have high amount of salinity, that decreases the amount of the dissolved oxygen that is present in water. And the third most important factor is the atmospheric pressure. As you keep on increasing the pressure, the dissolved oxygen also increases. That can be very well established when we see that in high altitude, the water holds less amount of oxygen. Okay, so these three important factors determine the amount of dissolved oxygen that will be present in a water body. Now coming on to the BOD, which is biochemical oxygen demand. That means a thing which is being needed by someone. Demand I put is in the form of microbes or the aquatic life forms that is present in the water body. They demand a certain amount of oxygen for their survivability, and therefore we call it the biochemical oxygen demand, which is the amount of dissolved oxygen consumed by the microorganisms for the biochemical oxidation of the organic matter. Then we call it as a carbonaceous biochemical oxygen demand, or it may be for the oxidation of the inorganic matter, which is called the autotrophic or nitrogenous biochemical oxygen demand. So, the components of the BOD can be CBOD or NBOD. Each and every water sample cannot go in for the BOD test at random. There are certain criteria which has to be followed when a water sample goes in for the BOD analysis. It must be free of chlorine. It should not have any chlorine because it inhibits the BOD process. Chlorine is a very good oxidizing agent. So, if the sample is having chlorine, we should always put a dechlorination agent, and that dechlorination agent can be sodium sulfide. The second criteria is the pH of the water sample should be in the range of 6.5 to 7.5. Water should not be highly acidic or it should not be highly alkaline. And the third most important criteria is it needs to have an adequate microbiological population, because we are going to assess the oxygen demand that is put up by the microbes. The certain amount of microbes should always be there. If it is not there, you won't be able to measure the BOD. Now there is a test which is called the inhibited BOD test. Now this is called an inhibited BOD test because I have told you that BOD has got two components, CBOD and NBOD. So if you only talk about BOD, we are taking into both. And if we are able to inhibit one of the BOD, we are considering only one. And that is why this is called an inhibited BOD. In this process, inhibition of the nitrification means the nitrogenous biochemical oxygen demand which is put up by the microorganisms in order to oxidize the inorganic matter has been inhibited by the addition of an agent which is called 2-chloro-6-trichloromethylpyridine at a concentration of 10 milligram per liters. So if this is added, it does not hamper your carbonaceous BOD, but it inhibits your nitrogenous BOD system. So let us determine the dissolved oxygen with the help of a test which is called the Winkler's test. In this Winkler's test, the first step says that when manganese sulfate and alkali iodide azide is added to an experimental water sample or any water sample you want to assess for BOD, manganese sulfate reacts with this hydroxide and there is formation of manganese hydroxide precipitate, and this precipitate is white in color. Now this precipitate could not be easily collected because the oxygen which is present in the water sample reacts with manganese hydroxide precipitate and you have formation of this manganese oxide. Now this precipitate manganese oxide is brownish orange in color, and what we are able to see is this precipitate with our naked eye, but not the precipitate of manganese hydroxide because it immediately reacts with the oxygen. Now in the second part of this reaction, we find that this precipitate again dissolves when we add concentrated sulfuric acid. And you have the liberation of manganese hydroxide along with the iodide. This iodine is released because here we have added potassium iodide. So when we add sulfuric acid, not only the manganese hydroxide is being released, you have the release of iodine from Ki. And therefore, if we are able to measure the amount of iodine which is released, we indirectly measure the amount of oxygen that was present in that water sample. So for that, what we do is we use thiosulfate for the titration process, and starch is used as an indicator, because when starch reacts with iodine, you have formation of a blue-black color, and therefore with the titration of thiosulfate, this blue-black color disappears and that becomes the end point of the titration. Now let us learn about the procedure of the BOD determination. Now, collection of the water sample for BOD determination is a very important and crucial step. You cannot collect any water sample in a beaker or conical for the BOD determination, and therefore there are some specialized glass bottles which are called the BOD bottles, in which the water sample are collected for BOD determination. Here you can see in this picture that the BOD bottle where you are going to collect the water has to be immersed inside. That means the capping of the bottle after collection of water should be done in such a way that the oxygen from the external environment should not get into the BOD bottle, and therefore the BOD bottle is immersed inside the water and you place the cap over the BOD bottle inside water only. Therefore, you are going to determine the amount of dissolved oxygen that is present in water and not the oxygen which is coming from the external source or from the external environment. Now, after this, we add about 2 ml of manganese sulfate to the collected water, and this addition of the manganese sulfate should be done with a calibrated pipette man immersed inside the bottle. That means there should not be any oxygen or bubbling in the water. After addition of this manganese sulfate, we again add 2 ml of the alkali iodide azide reagent in the same manner without disturbing the water sample. Now, after both of these are added, we find a development of a brownish orange precipitate which is of manganese oxide. That means the oxygen that is present in the water has reacted with the manganese hydroxide, which was a white precipitate. Therefore, we are not able to see the white precipitate, but we are able to observe the brownish orange precipitate of manganese oxide. After this precipitate settles down in the bottom, we add about 2 ml of the concentrated sulfuric acid and the precipitate completely dissolves. And there is presence of potassium iodide which breaks up and it releases free iodine, and this free iodine has to be measured for the assessment of the oxygen. Now, this BOD bottle has got 250 to 300 ml of water, and the whole thing could not be titrated at once. So what we do is we go in for 3 titrations. In each flask we take about 50 ml of this treated water, and to it we add 1 ml of the starch solution, and after this addition we find a blue-black color develops because of the presence of the free iodine, and this is titrated with sodium thiosulfate. When this is titrated with sodium thiosulfate, this blue-black color disappears and there is formation of a transparent color liquid. And that is the end point, and we find out the amount of sodium thiosulfate that has been required for the titration process. So, in this way, we find out the amount of dissolved oxygen. Now, how to go in for the calculation? We have to find out the biochemical oxygen demand. Now, this dissolved oxygen which is calculated at day 1 is referred to as dissolved oxygen or DO1. If the same amount of dissolved oxygen is calculated after a 5-day period, this is called DO5. Now, during this 5-day period, another bottle is kept inside the incubator at 20 degrees Celsius in a dark, and after 5 days of period, the dissolved oxygen is measured. So BOD in milligram per liter refers to DO1 minus DO5. Okay, where we say that DO in mg per liters is calculated with this formula where 8 is a constant, 1000 refers because we are finding it out in 1 liters, N is the normality of the titrant, and this V is the volume of thiosulfate that is required. And this capital V is the volume of sample that has been used for the titration in each test. So in this way, we find out the amount of dissolved oxygen in milligrams per liter. Coming on to the second test, which is called COD or chemical oxygen demand. Now this chemical oxygen demand is the amount of oxygen which is necessary to oxidize the organic carbon completely to carbon dioxide, water and ammonia. That means when we calculate the COD, we are basically oxidizing the whole organic matter, whether this is the organic compound or the biological entities which is present in that water body. So everything which is organic in nature will be oxidized, and we find out the amount of carbon dioxide, water and ammonia.
Ma'am, what is the difference between BOD and COD?
BOD is the amount of oxygen that is required by the microorganisms in order to oxidize the organic matter, in order to oxidize the inorganic matter. But the COD is the amount of oxygen that is required or that will be required by the system in order to oxidize everything, whether it's an organic matter or whether it's a biological entity. In the first step, we take 50 ml of the water sample and we add about 1 ml of mercuric sulfate and 1 ml of silver sulfate and about 5 ml of potassium dichromate, which is used as an oxidizing agent.
Ma'am, what is the significance of using mercuric sulfate and silver sulfate during determination of COD?
Now, mercuric sulfate is used to remove the complex chlorine compounds, because if the chlorine compounds is being formed, they act as an oxidizing agent. Therefore, if we find out the COD of a water sample which is having the chlorinated compounds, the chlorine basically oxidizes the thing and therefore the COD value goes down. And in the case of silver sulfate, this acts as a oxidizing agent for short straight chain organics and alcohols, and therefore it helps in the process of oxidation to find out the COD of a water sample. Now another bottle is taken where we do not take the water sample but we take simply the distilled water as a control. So we have two conicals, one with the water sample where we have added all the reagents and one with the distilled water where we have again added all the reagents. The one with the distilled water is set as a control. Now when everything is added, we incubate both the flask, the control as well as the test sample at 100 degrees Celsius for 1 hour in a water bath. Now after this, we remove the flask. That means after 1 hour of incubation at 100 degrees Celsius in a water bath, we remove the flask and let them cool, and then we go on to the other step where we add 5 ml of the potassium iodide solution along with 10 ml of the sulfuric acid. Now these steps has to be done in both the flasks, one in the control and the one which is going on for the test. Now 0.1 or 0.1 molar sodium thiosulfate solution is taken in a burette and it is titrated along with the control and along with the water sample. And after the titration, we find that a pale yellow color appears. Now after this appearance of the pale yellow color, we add about 1 ml of the starch solution. And immediately after the addition of the starch solution, we find that a blue-black color is being formed and titration is continued till we find that this blue-black color, here you can see in this flask, is changed to transparent color. That means this is the end point when the blue-black color totally disappears and becomes colorless. Okay, so this is the amount of the titrant, that is the sodium thiosulfate, required to convert this reaction to the end point. Now COD in milligrams per ml is calculated by this formula where 8 is a constant and C is the concentration of the titrant, that is the sodium thiosulfate, whether you have used it at 0.1 normal or whether you have used it at 0.2 normal or 0.5 normal. The VA is the volume of the titrant that is used for the control set where we have added distilled water, not the treated or the wastewater. And VB is the volume required, that is the volume of the titrant which is used for the titration in order to test for the wastewater or for the water sample. And this is divided by Vs, that is the volume of the sample water which is taken or which has been started for the titration process. Now we know what is BOD and what is COD. Now let us go on to the relationship, whether they are related in some way, whether this data help us in some way or not. Let us consider this sample 1. We find that the COD of this sample 1 is 2150 milligrams per liter, whereas the BOD is 1100 milligrams per liter. And if we go on to the ratio, we find that it is coming about 1.95. This water sample has been titrated thrice. And if we take the average of all the 3 samples, we find that it is about 1.9. This water sample is coming out from a food processing industry and the ratio therefore comes out to be 2:1 or 1.9:1. Now this COD is always higher than the BOD. Okay. In the case of the dye industry, we find that the COD-BOD ratio is about 5:1.
Ma'am, why does COD has a value greater than BOD and what does this indicate about the wastewater?
COD means when the organic compound or the organic matter is being totally oxidized with the help of the oxidizing agent which is potassium dichromate. Therefore, the organic matter which is present, that means the nutrients and everything along with the biological entity that is present in the water is going to be oxidized, and therefore it takes into account the whole thing. The value is always larger. But in BOD, we are finding out the amount of oxygen that is required by the microorganisms. Okay, and that is why the BOD level is always smaller or much lower than the COD. And if we go on to the significance, we find that, for example, here you can see in the case of dye industry, this is 5:1. So heavy amount of nutrient is coming in the water body and therefore it takes much more value of COD. Whereas in the food processing, it is 2:1, which is not so in the case. Therefore, a high COD to BOD ratio indicates that it is coming out from the industry and not from a domestic household. And the third important test which we perform is called TOC. Now, TOC basically refers to the total organic compound. And basically, there is no fixed method of determining the TOC. Because here we determine the total amount of carbon compound that is present in a water body. So this if total carbonic compound is being converted to carbon dioxide, and if we measure the carbon dioxide with the help of an infrared analyzer, we are able to say that how much amount of organic matter is present in a water body. And therefore this test is called the total organic compound. And no fixed biochemical test is available in the laboratory for this analysis. So all this shows that the wastewater which is coming out from the domestic household or from the industry can be analyzed and can go in for the primary, secondary or tertiary treatment, where it can be converted to a much better water and can be used for the irrigation or for the recreational purposes like swimming, health clubs, etc. Though we know that 3/4 of the earth's surface is covered with water, but still we have scarcity of water. So why not utilize the wastewater for other purposes and use the groundwater for the potable system or for the drinking purpose? Okay.